Hey guys, today we're going to start chapter 4, and the first section is 4.1, which is on maximum and minimum values. Now the first thing we need to look at for this is what's called critical numbers of a function. So I've got the definition here. A critical number is of a function f is a number c in the domain of f such that either f prime of c is 0 or f prime of c is undefined. Now why do we care about critical numbers? Because critical numbers help us find the maximum and minimum values of a function. If we look at a function like y equals x squared, or let's turn this around, make it into some random parabola: 8 minus 2x squared plus something plus x. This parabola, it's going to have a derivative of 0 up there at the vertex, and that's so the x coordinate of the vertex is a critical number. Similarly, if I graph the absolute value of x, this has a critical number down there at the vertex of the v, and that makes that's a place where the derivative is undefined. So that's the sort of the motivation behind finding critical numbers. So let's look at some examples. Well, first up, here are the instructions for finding critical numbers. First, you find the derivative. Then you set the derivative equal to 0 and solve. And the solutions to that are going to be your critical numbers. Now, there is a third step that you have to do sometimes. This one gets forgotten because it doesn't always have to be done. But this third step says check for any number c for which f prime of c is undefined. And that can happen if the most common reasons for it to happen are if your function has a denominator. Any value that makes that denominator 0 is going to be a critical number. And sometimes if you have a trig function, you might have some other values that make it undefined. So let's do some examples. This first example we've got is a parabola. Find the critical numbers of this parabola. All right, so take the derivative. So we get 6x plus 5. And I have a cat standing on my iPad. This is Veronica. And try to get her to participate a little less. All right, 6x plus 5 is our derivative. If you set that equal to 0, you get 6x is negative 5. So x is minus 5 over 6. And that's our critical number. And if we were to graph this, we could see that negative 5 over 6 would be the x-coordinate of the parabola, of the vertex of the parabola. All right, 112. On this one, we've got this cubic function, x cubed plus 4x squared plus 4x minus 1. So let's take its derivative. And I'm just copying the function. Let's take the derivative. 3x squared plus 8x plus 4. All right, now I've got to set that equal to 0 and solve. So if we do that, we could try to factor this, but I don't think it's going to factor. So let's just solve it with the quadratic formula. X is going to be minus 8 plus or minus the square root of 8 squared minus 4 times a times c, all over 2a. So let's see, that's 64 minus, let's see, that's 48. Oh wow, that's surprising. Plus or minus the square root of 16 over 6. So it's negative 8 plus or minus 4 over 6. I said that was surprising. I didn't expect this discriminant to turn out to be a perfect square. What this means is if I had tried, I could have factored this. But let's see, what do we get? We get negative 8 plus 4 over 6. So that's negative 4 over 6. So it's negative 2/3. We also get negative 8 minus 4 over 6. So that's negative 12 over 6. So that's negative 2. So those should be the our critical numbers. Now let's look at this one on Desmos. All right, I'm going to put the function in first. Let's see, our function is y equals x cubed plus 4x squared plus 4x minus 1. All right, so we get this, and the critical numbers are going to be the value here at the x value at the peak and the valley there, the max and min, local max and min. We'll define those later. Let's see, y prime. Tell you what, I'm going to call this f of x. And if I just put in f prime here, it will calculate that for me. And notice Desmos highlights the places where the derivative crosses the axis. Sure enough, it happens right here at negative 2 and over here at negative 2/3. All right. Let's do another example. Find the critical numbers of this. All right. Tell you what, let's do before we find these. Let's graph it and see what it looks like. Eventually, I'll get on the right screen. Let's see. Y equals, or I'm going to call it f of x again. Let's see. X squared plus 1 over 1 minus x squared. All right, we get this. Interesting. Now notice 1 and negative 1 are outside of the domain of this function. So looking at the graph, it looks like 0 is going to be a critical number. But let's work that out. If we take the derivative of this, y prime is going to be low d high minus high d low over low squared. All right, let's see, this top turns into 2x minus 2x cubed, and then plus 2x cubed plus 2x. Let me just double check that for a second. Yeah. All right. So when we put that together, the top is, let's see, the 2x cubes cancel out. We're left with 4x over 1 minus x squared. All right. So to find the critical numbers, what we need to do is set the top equal to 0. So that gives me 0 as a critical number. We also would set the bottom equal to 0. And take the square root of both sides. You get this. X squared is 1, so x is plus or minus 1. Technically, those are not critical numbers because 1 and negative 1 were not in the domain to begin with. So the only critical number we get here is 0. All right, let's do this next one. Find the critical numbers. This might be a little hard to see. Critical numbers of this function. Y equals x to the 2/3 times x plus 5. All right, we've got a couple of options for how to do this. We could use the product rule, or we could distribute that x to the 2/3 across and do that. Let's distribute it across. So I get x to the, let's see, add 1 to that, so you get x to the 5/3. Let me draw this a little bigger. X to the 5/3 plus 5x to the 2/3. That's my y. So my y prime is going to be 5/3 x to the 5/3 minus 1 is 2/3. And then 2/3 times 5 is 10/3. X to the negative 1/3. All right, now there's a couple of things we could do here. What we should probably do, the best way to do this, because we've got to find the values of x that make this thing 0. 0 is obviously one of them, but is there anything else? I don't know. Let's factor out x to the negative 1/3. Now this might look a little weird, but I'm going to come over here and I'm going to do x to the negative 1/3 times. Well, let's see. We could factor some other stuff out. We could factor out 5/3 and x to the negative 1/3. Okay, this confuses people sometimes, so let's do a small example down here. Let's say we had 2x to the 5th plus 4x to the 7th. If you wanted to, you could factor out a 2x to the 5th here. And what's left is x to the 5 minus 5 plus 4x to the 7 minus 5. Now normally, I'm sorry, I had that off screen. Normally you wouldn't do this middle step here because you just think, oh, I just pull out the 2x to the 5th and it leaves me with 1 and then 2x squared, or 4, yeah, 2x squared. So normally you'd probably leave that middle thing off. But let's look up here. When we factor out 5/3, what we're left with here is, from this first term, we get x to the 2/3 minus negative 1/3 plus 10/3. I factored out the 5/3, so that leaves me with 2. X to the negative 1/3 minus negative 1/3. So this leaves me with 5/3 x to the minus 1/3. And then this becomes x to the 2/3 plus 1/3 is first power, is 1. And then plus just 2. So that's my derivative. And I would probably rewrite that as 5 times x plus 2. And then move leave the 3 down here and rewrite the x to the negative 1/3 as cube root of x in the denominator. All right, so now what we have to do is set the top and bottom equal to 0. Setting the top equal to 0 gives us, this will tell us where the function is equal to 0. That's going to give us x equals negative 2. And setting the bottom equal to 0 will tell us where the function is undefined. So that just gives us x equals 0. So this function has two critical numbers, x equals negative 2 and x equals 0. At this one, f prime is undefined. Or no, at this one, f prime of x is 0. So let me write this. F prime of negative 2 is 0. And f prime of 0 is undefined. Let's look at that on Desmos and see why. So the function we're looking at here is x to the 2/3 times x plus 5. Put my equal in there. And notice what's going on here. We've got two critical numbers. Up top, right here, at x equals -2, the derivative is 0 because we have that rounded hilltop. And over here at x equals 0, we've got this sharp corner here. So that's why the derivative is undefined there. And if we got this to graph the derivative for us, the derivative looks like that. But anyway, those are the two critical numbers for this function.